All right, graphing inequalities. When dealing with inequalities, we use less than, greater than, less than or equal to, greater than or equal to, instead of the equal sign. Okay, so we no longer deal with the lines themselves. We deal with the area either above or below the actual line. And inequality does not only deal with the points located on the line, but also with the points that are either above or below the lines. Okay. Page 17. We indicate this by shading the area, right? We'll be shading the area either above or below what we call the boundary line. So the inequality, negative 2x plus 4y is less than 16. Pay close attention to this. So this is the inequality. I call this IQ. Okay. Would have a boundary line of negative 2x plus 4y. What's the only difference between this and this? Is the inequality, that symbol. This is the line. So if you have an equal sign, then it's a line. We can't consider that the boundary line. When it has an inequality, it's an inequality if that symbol is there. But this is the boundary line we're going to draw, and then we're going to focus on the inequality. And so we split the coordinate plane into two planes. We can call the planes regions. Okay, you can go arrow to it, also known as regions. In this unit, we will shade using regular or reverse shading. And here is a visual as to what I mean by that. When it's regular shading, we shade the true region. Whereas, if it is reverse shading, we shade the false region. And this is what I mean by that. It'd be nice to have a ruler for this unit actually. We do a lot of lines, right, graphing lines. It doesn't matter where on here the line goes really, but I'm going to put it right here. If this is your boundary line, okay, let's make a copy of that. I'm going to try to make an exact replica of it over here. It splits. I don't know if you've seen, if you can, right? This line splits it into two regions. Right? So one of the regions we're going to determine is what we call the true region, the true plane. And the other one is therefore, if one is true, then the other one is by definition false. And so that doesn't change. We're going to remember this is a copy of each other. So we're going to take this over to this side as well and say this is true and this is false. All right. Now, this is what I want you to remember because sometimes it can get a bit confusing, and I'm going to tell you why later on, why I will use reverse shading down the road, because it will make our lives a lot easier. The true region, I'm going to circle it with a red pen here. If you have a different color pen or marker, the true region does not change at all. It's just what we shade that changes. Okay. If you use the regular shading, if I ask you to use regular shading, we shade the true region. So I put my ruler right against the line and I start shading the true region. I don't press too hard, I just lightly, because any labeling or whatever, We want that to still be visible when we're done. Okay. So we've shaded the true region there. If we use reverse shading, guess what? We're going to be shading the false region. The true region didn't change, right? So I'm going to highlight that part. The true region does not change, only what we shade. And I'm going to say this, I'm going to say it many times. I really don't care if you shade regular or reverse. I care more about where is the true region. Okay? So always tell me where is the true region. So sometimes I'm going to say true region. Sometimes I'm going to use solution. I'm going to call that the solution region. So I go back and forth on that. Okay, let's keep going. Another concept you need to understand is the difference between dashed and solid boundary lines. Okay, so if you have these symbols that do not have an equal under them, we used a dashed line. Points on the line are not included in the solution. Whereas on the right side here, when you do have the equal sign underneath the inequality symbol, that it results in a solid line. And so in that case, points that are on the line are also included in our solution as well. So to differentiate, we use dashed versus solid. So let's make the lines go up. I'm going to make one here. So dashed line, right? Dashed line. And we can make another scenario where you have a solid line. And because we're dealing with inequalities, we're going to actually, I'm going to shade the region under here. I'm going to call this the true region. So we're using regular shading in this case. And then on this, we're doing the same thing. True is here. I'm going to shade underneath here as well. Yeah. So I'm just going to give you a scenario. Let's say this point right here is 2, 3. Label it like that. And that exact same point is going to also appear over here. 2, 3. So it's a copy. Those lines are exactly the same. One is dashed, one is solid. And let's just drop just underneath it here and call this 2, 2. Same over here. We're going to make another point right here, 2, 2. Over here, we would say not a solution. The 2, 2 is a solution. Okay, 2, 2 would be, because it's in the shaded, in the true region, I should say, 2, 2 is a solution, but 2, 3 is right on the line. Since it's dashed, it's not a solution. In this case, we would say is a solution, also is a solution. So keep that in mind. By the way, if we just had, I'm just going to make this one up here. So 3, so let's go -5, -5, 2. This is also not a solution. Why is it not a solution? Because by definition, which region is this one in? If it's not the true region, then this is the false, right? And so any point that is not in the true region is not a solution. We call that as not a solution. So same over here. If it's negative 5, 2, obviously this is also not a solution. So just concepts that I'm covering here before we dive in. Let's keep going. Should I wait a little bit? Slow down. Good? Okay, let's keep going. 18. I'm building it up to so that later on when we work with inequalities, you'll be like, okay, I know, I've heard this terminology before. Here is rules when working with inequalities. That's very important as well. I'm going to use a different color for this next part. When multiplying or dividing inequalities by a negative, we need to flip the inequality symbol. That is so important. I'm going to make it even. I'm going to make that stick out even more. That is a very, very important concept. Important. Don't forget about it, because it will bite you if you forget about it. So for instance, if this inequality, and you could tell this is true, correct? 2 is less than 5, correct? I think everybody would agree in here. But what if I do the same thing as an equation and I divide both sides by, let's say, negative 1? If I do that, 2 divided by negative 1 is negative 2. Okay? 5 divided by negative 1 is negative 5. If I kept that inequality like this, if I kept it, is this true? Is negative 2 smaller than negative 5? That's false. Okay? Therefore, flip inequality symbol. Okay? So you need to make up for that change. So we're going to go negative 2, negative 5, and we use a red pen. I'm going to flip it the other way. Okay? Flip the inequality symbol. So every time you multiply or divide by a negative, that whole inequality, you have to flip the symbol. I'm going to give you a quick example here. Example, you have negative 3x minus 2y is greater than or equal to 10, let's say. Did you know that you can work with them just like you would with an equation? You can do the same thing. You can bring stuff over. So if we brought the 3x over to this side, that would leave us with negative 2y is greater than or equal to plus 3x plus 10. The 3 came over positive. I'm going to put a positive in front of it. Okay? Nothing changes. The sign does not need to be flipped. We do not flip because we didn't divide or multiply by a negative. We just brought stuff over. But the next part, if you want to get rid of the negative 2 in front of y, which is what we're going to do quite often, if you divide by negative 2, watch out, okay? Watch out on this part. I would actually say take this symbol, flip it the other way right away. Okay, flip. And then do your division. So this would be positive y This would be negative 3 over 2x, and this would be negative 5. Okay, so see, this looks like the rewritten form of our equation before. We're going to do that a lot as well. So it went from facing the point, right? The tip faced this way. All of a sudden, it's facing the other way. Why? Because we divided by negative. Let's keep going here. Am I going to show you the shortcut right away? Okay. So the graph of this inequality is given below. This is an example of regular or reverse shading. How do we know? Okay. This is how we would know for sure. Choose a test point. Choose a test point. Which point are we going to test? Which one are we going to pick to test? I know I've given you a point there and there. Let's just go with 0, 0. 0, 0, you can clearly tell is in the shaded region. Just keep an eye on that. So let's put this test point into this inequality and see if it's true or false. Right? We're taking that, plugging it in there. You could have picked any point. I like 0, 0 the most. So we're going to go 0, 0, right? So we're going to substitute that in. So that'd be negative 2, 0 plus 4 times 0. And that's supposed to be less than 16. We know that all of this is just going to be 0 is less than 16. Is that true? Is 0 less than 16? I think all of you would be like, yeah, for sure. This is true. Okay. Since, so let's make a note here. Since our test point makes the inequality true, the region in which, can you read that? Let me zoom in. There. The region in which it is located is also true. Since our test point makes the inequality true, the region in which it is located is therefore true. We just take one point, check it. Is it true? Well, then everything, that whole pane is going to be true as well. So let's go over here. You were checking in that shaded region. So we can confidently say, oops, true. Okay. The point is in the true region. We checked. Therefore, this whole shaded region, everything below the line, is going to be true as well. So by definition, what's the unshaded part? False. Okay. So what type of shading has been used? Regular, because the true region has been shaded. Regular shading, since true region is shaded. I kind of, yeah, I should have made this space a little bigger. Here's the shortcut. I hope you have some space there. No. I'm not going to do that. It's going to mess everything up. But there's a shortcut, okay? And here's the quicker way of doing that. Instead of doing the test point, there's a quicker way of doing that, and I'm gonna show it to you. You need to have everything in isolated form. You need to have y on its own or x on its own if it pertains, right? So if you have y is less than or y is less than or equal to, the true region is below line. So we're going to go true is below like this. That's going to be our code for saying, for indicating where the true region is. On the other hand, if you have y is greater than or equal to, true region is above. Can I say, I think I need to, for me this makes sense, but it's below the line, above the line. So this is the more common one where y is always going to be slanted, correct? Or horizontal. When you have x, right, then you have a vertical line. So when it's x less than, then it's left. So we would go true is to the left like this. And when it's x is greater than, our true region is to the right. So that's the key, that the code that I use here. I'm going to use these, the true above or below, right, or left, right. And here's a bit of a graph to help you out. So you can just sketch this one, right? So if you have your axes, right, and you're graphing a line, it doesn't matter if it's solid or shaded, or solid or dashed, sorry. If this is the line, right, this is the boundary line, and you have y is less than, then true region is going to be here. Okay. I'm not shading, I'm just telling you where the true region is, because that's what matters. Guess what? You could have a horizontal line. Let's make it dashed. And in that case, the true region would be below that horizontal line. Okay? And so the same thing goes here. You could have a dashed line going this way. Some students have a hard time figuring out where above the line is on this one, on slanted, but just think about it. This is the line, then above it would be, right, above it this way. So the true region is here. Or let's make a horizontal that is solid. This is my actual line, so the true region would be above here. Here I'm only going to have one graph, okay? I maybe should have used a red pen to really emphasize the actual line. There we go. And left, so if you have a vertical line, it doesn't matter. It could go, if it's just x, it's going to be a vertical. And if it's x is less than, it doesn't matter what's on the other side, this is going to be your true region. And on the other hand, if it's if this is the case and you have a dashed, let's say it's a dashed one, the true region would be to the right. Remember, I'll maybe make a note under this. The main focus is to find the true region, okay? That is going to always be our main focus. Where is the true region? And therefore, by definition, we'll find the false region because it's whatever is left, right? So the main focus is always where is the true region? So let's put this to the test. Let's start working with it. So this, I don't know if you need the actual graphs, but I would have a little cheat on my study sheet just with those entries there, because then you know it's a quick reference, okay, above or below. Good? Don't fall asleep on me. So let's graph inequalities here. For each of the following, determine the intercepts, rewrite, and then graph using regular shading. So for now, we're just going to use regular shading. Just keep it simple. Okay, so remember, this is the inequality. This is the boundary line. I will not write out the boundary line every time, but it's basically the exact same thing, except where it has the equal sign. Okay, that's the only difference, the inequality boundary line. So to find the intercepts, we focus on the boundary line. We want to be able to graph that line, and then we shade based on where that line is. It's kind of like the cutoff region, the cutoff line. So I always like to make it look a little more like the standard form. So I bring the 10 over, adding like that. I like this version more than having 0 on the other side. This is going to be a lot easier to find our intercepts. So x-intercept, y-intercept. Okay, you already know the drill here. X-intercept, y is equal to 0. So it's just 4x is equal to 10 because the y, this whole thing is gone. So 4x is equal to 10. Divide both sides by 4. X is equal to 2.5. 2.50. Here, you're allowed to round to 2 decimals because this we only use to help us graph it on paper. That's the main reason we use this. Y-intercept, our x is equal to 0. So we end up with negative 5y is equal to 10. Divide both sides by negative 5. I repeat, negative 5, right? So don't forget about your signs. 10 divided by negative 5 is negative 2. So our y-intercept is 0, negative 2. Box that in nice and neat because let me tell you, later on when you have 2 or 3 at a time, you want to have everything nice and neat, cleaned up, organized. So I'm helping you do that. So I use my boundary line to determine the intercepts. I can tell you that this part I don't really have on my key. I just do it like I just look at this and just treat it as if it's an equation. But anyways, let's rewrite. So this is the rewriting part. 4x minus 5y. The inequality symbol stays. The 10 comes over to the other side. Plus 10. Let's go plus 10 just to emphasize the point. Then I bring the 4x over to the other side. So I'm left with negative 5y is greater than, what happens to the 4x? Comes over, subtracting, plus 10. Okay, now what? What am I going to do next? Divide by negative 5, right? So you basically are rewriting this into the y mx plus b format. Divide this by negative 5, divide this by negative 5. You should immediately say, oh, I'm dividing by negative. I'm going to flip it the other way. Okay, flip. So I'm left with y. Negative 4 divided by negative 5 is just positive 4 over 5x. 10 divided by negative 5 is negative 2. This jives with our previous findings. Okay, that should jive. If you don't have the same y-intercept, you're in trouble. You've rewritten it. Perfect. Where's the true region? Okay. Well, this symbol tells me that it's dashed. The true region is where? If it's less than. It's actually y is less than, right? It's going to be below. That's what it's telling us. Okay. So let's go and graph it. Oh, wait, one more thing. Dashed, true is below. We're going to shade below. So watch what I do here. This is the code later on. True is below, shade below. We're shading the same area as the true region is in. So dashed, true is below, shade below. So let's go ahead and do this. So we have our grid. I would still want you to always label your axes, put arrowheads, x and y. I already have a scale, beautiful. 2.5 is right here, 2.50. And 0, negative 2 is right here. Let's go ahead and grab our ruler. And this is going to be dashed. I've already determined that. Go right across. So this is what we call the boundary line. This is, and I label it like this. Does that make sense that it's going up? Well, look at your slope. It's positive, right? Positive slope 4 over 5. That means it's going to be increasing from left to right. And we're going to say that the true region is below. Sorry. True. I meant to say true. So this is the line. Everything underneath it is true. And therefore, we're also going to shade because we're using regular shading right now. All right, so there you go. That's your first inequality. Let's say you're like, I'm not sure about this. The true region, I need more help with that. If you want to do a test point, right, I always pick 0, 0. Where is 0, 0 in our case right now? Which region is it in? In the false region, correct? So I would expect, if I plug this into that original inequality, I'm expecting my answer to be false. So let's try that. 4 times 0 plus, minus 5 times 0 minus 10 is greater than 0. That's what that statement is saying. All of this is negative 10, because this is 0 and 0, you're just left with negative 10, right? This is false. Therefore, the area surrounding 0, 0 is false. So it's just a slightly different approach, but it works every time. Okay, we knew that this was false. In fact, any point in this region is going to be false, but we don't want to test them all. We just want to test one and come up with our solution. Okay, just to further emphasize the point, is 40-30 part of the solution? I want you to show your work when I ask you a question like this. I don't want you to just guess, because it's 50-50. Right? Where is 40-30? Just let's picture it. 40-30 would be 40, you would have to go way over here, and 30 would be way up here. So we don't know if that's going to be in the solution region based on our graph. Not for sure. So what you do is you just substitute that in. Okay? Plug into original inequality. Look at that. I managed to squeeze an OG into my lesson here. Into the original inequality. Is that going to throw you off? Anyways. So we take that. So it's 4 times 40 minus 5 times 30 minus 10. I recommend taking the very original inequality. That's your best bet. So this is 160 minus 5 times 30 is 150 minus 10 is equal to 0. And this is actually 0 is greater than 0, right? If you do 150 minus 160 minus 150 is 10 minus 10 is 0. Is this true? 0 is not greater than 0. Okay, so this is false. Therefore, 40-30 is not part of the solution. You would do the same thing with the other one. I'll show you here. So we have that. That's negative 80 minus 250 minus 10 greater than 0. You have all negatives. I'm surprised we're not writing a test or something, because that's when these guys show up. It's test time. Anyways, that adds up to negative 340. It's greater than 0. This is false. Therefore, negative 2050 is not a solution. And you notice that I'm answering not part of the solution region, and then sometimes I say it's not a solution. It's all saying the same thing. I want to do one more before we go, before I leave it up to you here. And then I want you to practice a little bit. So let's go over to page 20. This is a special case, right? I will say if you scan it, there's no y variable. This will be a vertical boundary line. That's something you should catch. If there's no y variable, it's not going to be a diagonal. It's going to be either, it could be the other way. If there's no x variable, just a y, then it's a horizontal. So what I do here is as follows. No need to, I'll put that note on the side because I like to do the work right underneath here. No need for intercepts. Okay? You don't need to find them, you just rewrite. Just rewrite. So I will go 3x. This x comes over to the left side. Okay, so that comes over subtracting minus x is less than 6. 3x minus x is 2x, which is still less than 6. We divide both sides by 2. Do we need to worry about dividing by 2? No, we don't flip any signs or anything because it's not negative. So x is less than 3. Okay. What do we know from this? It's going to be dashed, right? This tells us dashed. It also tells us true is where? Is when it's less than, x is less than, it's left. So true is to the left like this. And we will shade left as well. So shade left. That's going to be my code here for you. So the inequality tells you a bunch of things. Once it's rewritten, you can't make the true region assumption when it's not completely isolated. Okay, you have to isolate first. So here we go. Where does this one go through, you think? If it's positive 3, it's going to go right through 3, 0 here, vertical. So it's going to be dashed like this. There we go. This is x is less than 3. Oh, I'm just going to say vertical line. Vertical line. Okay. And so the true region is here. This whole thing is true. Everything to the left of it is true. So you just put your ruler there. Everything to the left is true. Let me just check 1 second. Okay, we're not going to do that part today. We're going to leave that for tomorrow. Just for your notes, I'm gonna give you these two here one more time. Vertical boundary line. If it's like this already isolated, this is going through -3. So you go to -3 here and make your dashed line. X is greater than -3. Okay. What do we know? This sign is telling us a couple of things. That it's dashed. It's already isolated, so we can just go ahead. It also tells us that the true is, if it's a vertical line, greater than is right. So true goes this way. So the true region is here. We're also shading right. So S goes that way. So true and shading go that way. So I put my ruler here and I shade in this area. Alternatively, if it's just y as a number, what do we know about this symbol here? It's going to be solid because there's an equal sign. The true region is going to be, if it's y is less than, the true region is actually below. And another thing it tells us is, in this case, we're going to shade the exact same region where the true region is. So we shade below. So it's positive 4, so we go right through here. It's solid, so we go solid line. This is y is less than or equal to 4. This is the true region. And you go ahead and just shade that area. Actually, everything has to be shaded, right? Technically, everything you can see there. So here it is. Pages. I'm going to skip 21 and 22 for now. So I just want you to go 23 to 25, but I'm going to post to 26. But you can't do it. The ones that are on 26, I don't expect you to do just yet. Okay. So practice doing the rewriting, the graphing, all of that. You're going to have to think it through at this stage.